Okay, for this question, we're asked to prove that the limit as xy goes to 0, 0 of x over x squared plus y squared does not exist. So it doesn't say really, it doesn't specify how or anything, but this already is a big clue. We know that it does not exist, so that means that either the limit from approaching it from one direction or one path does not agree with another, the limit as you approach from another way or direction or path, or, as we'll see in this example, something else different could happen. So first of all, a good way to start is to check the limit as you approach from or along the x-axis or the y-axis. So that just means you set one of them equal to 0. So let's do limit along the y-axis. Let's do that one first. So that would be setting our set x equal to 0. Okay. So if we do that, we have limit as 0y goes to 0, 0, okay, of x over x squared plus y squared. So that's going to equal 0 over 0 squared plus y squared. This is just equal to 0, which is fine, okay. So now let's see what happens along the x-axis. So limit along the x-axis. So conversely, that would be setting y equal to 0, okay. So if you set y equal to 0, let's see what goes on here. So we have x 0 goes to 0, 0, 0, 0, and then our x over x squared plus y squared. So that's equal to x over x squared plus 0 squared, which is equal to x over x squared, which is, hold on here. So we find that we can cancel out an x on the top and bottom, a single x, right? So we just get a 1 over x. And this, I guess I should have been, actually I should have had limit as x goes to 0 on all of these, right? Because y is just 0 already, so 0 goes to 0. That doesn't mean, that doesn't signify anything. So we just have x goes to 0, so this also is a limit as x goes to 0. Sorry about that. So then we end up with limit as x goes to 0 of 1 over x, which we would get a 1 over 0, which consequently is undefined. So what that means is that as we were approaching our this will be our conclusion. So approaching our f of xy from or also along the x-axis, the x. There we go. That was a funny x. Hold on. The x-axis gives us a limit that does not exist, right? Gives us a limit that, and I'll abbreviate, that does not exist. So our conclusion is going to be that the limit overall, so the limit overall, which was, I'll just write in parentheses, limit as xy goes to 0, 0 of x over x squared plus y squared. We're going to say that the limit overall does not exist. Okay, and thus we proved it. So this was another way that a limit could not exist, could not exist, is when if approaching it from a certain direction or path, if that gives you a limit that is undefined. So if from one curve, if you're approaching like your point P from one curve that just happens to not work and it gives you an answer that's undefined, then that means that the limit, the entire limit from all of those directions, from all the directions considered together, cannot exist and does not exist as well. Okay? Let me love you, baby. Let me love you. You have the best thing.